Great. So I'm Lucy, as mentioned. Our talk is called From Usability to Secure Computing and Back Again. So to provide context, a few years ago, the city of Boston wanted to create something called the Boston Women's Workforce Council. And they had a goal in mind of closing the gender wage gap. But in order to do so, they need actual wage data from companies in the Boston area. And these companies view this data as highly sensitive information that they don't want anyone to see in the clear. So what was originally proposed was that each business would take these spreadsheets of very sensitive information and hand them on over to a trusted third party. This trusted third party would then take all of these spreadsheets, aggregate them together, and provide the proper analysis needed. However, the lawyers involved realized that they were weary of any entity in the situation getting access to that data. So they were still worried that in the event of a data breach, their information would still be vulnerable and could possibly get compromised. So because of this, the trusted third party was also afraid that they would also face the liability risk of holding that data and then potentially being sued in the event of said data breach. So to resolve this problem, our team used something called secure multi-party computation. And this is a cryptographic technique that evaluates some function f on a set of private inputs, and then it produces some public output. Specifically, in our case, the private inputs are the salary data from all of these companies, and the public output is the average salary of men versus women. So we have now deployed secure multi-party computation a few times for this study, with results captured in the Boston Women's Workforce Council's reports, which you can all read if you're interested. And in the most recent deployment, there were over 100 companies that actually participated in this study and submitted their company data. And for all of these 100 companies, we had to explain the guarantees of MPC to them and also allow for their employees to successfully submit their data in a user-friendly way. And due to the privacy-preserving properties of secure multi-party computation, there are certain usability challenges that are introduced when we use this in the real world. So I'm going to discuss what these usability challenges are and how we've solved them in our deployments. And in the second half of the talk, Peter is going to talk about how MPC can be used to improve usability by providing privacy-preserving web analytics. Specifically, he's going to describe our implementation and how we've actually, how this has allowed us to analyze user behavior without compromising any of our original privacy goals or guarantees. And what this work demonstrates is that it's possible to measure and then improve usability of secure web applications without any additional privacy cost. So as MPC moves from theory to practice, our experiences have shown that MPC needs to be more accessible to our target users. They need to understand and use MPC without mistakes, which both contribute to their trust in our software's ability to protect their sensitive data and to produce accurate results. I'm going to highlight 3 particular usability challenges: 1, inspiring trust; 2, error minimization; and 3, ease of use. For more, they're discussed in our paper. So MPC is not yet used very often in practice, so its core guarantees and terminology are not necessarily understood by non-domain experts, nor are they concepts that people may ever have heard of before. So this puts an additional burden on MPC application developers to convey the guarantees of MPC to stakeholders and also have them buy into the idea that MPC actually works. And although we could show our audiences cryptographic proofs, they're not necessarily accessible to a broader population. So instead, we've tried to draw analogies or use examples with concrete demonstrations of how MPC works. So these analogies are not meant to actually explain every intricate detail of MPC, but they're meant to give audiences confidence that it's possible to compute a function on private inputs and not reveal any of those inputs. So we've accompanied these explanations with this diagram of our protocol, which is a semi-honest additive secret sharing scheme. And although more complex MPC protocols do exist, we chose a comparatively simpler one since it's easier to explain to our target audience. And I will demonstrate that by walking you all through it. So we start off with our contributors who hold the actual data. And each contributor then generates a random mask in the browser. And this random mask is encrypted under the public key of the analyst at the Boston Women's Workforce Council. This random mask then gets sent to the BWWC, where they can unmask it and then aggregate it together to create what is called the aggregate mask. So meanwhile, the addition of the actual data and the random mask produces something called the mask data. And this mask data gets sent on to the Boston University server, where we then compute the aggregate of these masked pieces of data. And then we have what is called the masked aggregate data. We send the masked aggregate data on over to the analysts at the Boston Women's Workforce Council, and they now have both sets of aggregate pieces of information. They can subtract one from another to then arrive at the actual aggregate data. So this is how we've explained our protocol to our users, and hopefully it's clear to you all as well. So error minimization is important in general, but it's especially critical in our setting. Since the inputs are private, MPC doesn't allow any single entity to look at that input data, which makes it difficult to detect and correct invalid input data and to remove outliers. And although we can build in certain error detection logic and encode that to run under MPC, this increases performance overhead in ways that may make the computation infeasible in some cases. And this also requires that we actually have logic formalized and written down about the data without prior knowledge of what the input data characteristics actually are. So we also want a high participation rate for the correctness and the validity of the study, but as the number of contributors increases, the chances that at least one contributor provides incorrect data also increases. All of these issues make it very critical for us to detect errors before data submission actually happens and to make this process as easy as possible. So to reduce the number of errors, we allow users to pre-fill a spreadsheet that they can upload to the platform. We also proactively provide feedback to warn users about missing or out-of-range data prior to their actual submission. For example, we can find out what the largest company in Boston is and encode that users can't enter a number larger than that. And finally, we permit users to resubmit their data if they discover that a previous submission is wrong, and by supporting resubmission, this also influences the underlying MPC protocols we can choose from, since not all of them accommodate this without modification. And here we have the actual user interface used by all of our participants. And they range from HR employees at hospitals, manufacturing companies, universities, tech companies, etc. And they have a very wide range of technical expertise as well as computational resources that are available to them at their institution. So we've done our best to make this process as seamless as possible. And as you can see, it looks like the original workflow where users just enter their spreadsheets, but the cryptography is running in the client and it's abstracted from the participants. So our application relies on familiar web interfaces and doesn't require a special setup process or specialized software or hardware. So in conclusion, as MPC moves from theory to practice, usability needs to be a key emphasis with care put into inspiring trust in both privacy guarantees and the correctness of the output. There also needs to be focus done on error checking before data leaves the user and reliance on familiar interfaces that non-domain experts already understand.
Thanks, Lucy. I'm Peter. So as Lucy said, or she sort of gave you an overview of the usability challenges we encountered and how we tried to address them and overcome them in order to eventually deploy this application using multi-party computation. Now I would like to look at the reverse direction and ask, how can multi-party computation be used to actually study and improve usability? So we'll present a sort of proof of concept design of how to collect usability metrics under MPC. So a common practice in web development is A/B testing, where you test various versions of a site or a UI design to test the efficacy or the success of different design decisions. And this in all applications, including applications with cryptography and multi-party computation, is very helpful to sort of evaluate the successes and failures of a design. Common platforms that help you do this are things like Mixpanel and Google Analytics, which provide helpful information for this. They also provide lots of other information about user interaction on a website. And in fact, they might even track users outside of the particular application that's using them. Some of these services even go so far as to recreate entire user sessions where an application developer could see everywhere a person clicked and scrolled and navigated, et cetera. So while this is potentially very useful information for evaluating and changing the design of a website, it's definitely not privacy preserving. There's a lot of user level input and individual data that we particularly do not want to collect. We specifically don't want to collect any user level data. As Lucy detailed, we spent a lot of time explaining to people the privacy guarantees of MPC and convincing them to use this application. So we don't want to undermine their understanding and their trust by introducing web analytics platforms that might collect individual level data. But as I said, it is very useful data for improving design or studying design. So as we have this MPC backend in place, we thought to introduce usability metrics into the private inputs of this computation so that we can get at least aggregate level usability metrics out on the other side. We implemented this in the system to add specific usability metrics that we thought would be helpful for evaluating our design and our application. So specifically, we chose to focus on what browser people were using, the amount of time they spent on various portions of the website, whether or not they use specific UI features, such as the drag and drop file upload, or whether people chose to manually enter their data. And we also counted the number of errors that they encountered while inputting data, whether their value was negative or not a number or too large, things like that. And so all of this was used to collect this data without collecting any individual level data. So the output of the process is still only aggregate and not individual. We use this to run a study across 3 different versions of the application. And I'll show you briefly what they looked like. So the very first design of the website is like this. And as you can see, there are red and yellow markers for if your data is potentially invalid or not going to be accepted at all. The second design that we tested is this, which is very similar. And there's a tooltip next to this red box, which explains why the data might be invalid or incorrect, so people can understand how to correct it. The third version of the application that we tested and compared is when we introduced the drag and drop file upload. So people could offline compile their data and input it into a spreadsheet and then just upload it and not have to manually enter every cell. So we ran this study with about 150 people. And to demonstrate what sort of data you could collect from a system like this, here's a graph of the errors broken down by which version of the application people were using. So this graph shows that the most recent version of the application with the file upload feature, users encountered the fewest errors. And again, as a demonstration, here's a graph of each version of the website and how long people took on average to use the application and submit the data. So here, actually, the most recent version took people the longest to use. So this process obviously has some limitations. One of those is that it limits the statistics and the granularity of the data you can collect. For example, in our case, we only collected averages, and we couldn't see if all of the errors in one group were produced by one user, and if that was representative of the whole group or not. Another limitation is that the application already needs to support MPC. In our case, we had 2 parties already set up, Boston University and the Boston Women's Workforce Council, that were prepared to receive and compute over this shared data. But in many web applications where they're only interacting with one server, this would not be possible. So to end, I'd like to show this graphic again and emphasize that these 2 ideas, or these 2 fields of usability and secure computation, can enhance and collaborate with each other. Our deployment really benefited from focusing on design and usability early on, particularly with things like error minimization and resubmission. For example, in the most recent deployment we had, we received an email from a contributor, or the Boston Women's Workforce Council did, who said, "Oh, could I please resubmit my data? I just wanted to try out the application, so I uploaded random data." And without the ability to resubmit, we wouldn't have been able to detect this, and that would have affected the validity of the output data, or the correctness of the output data. And on the other hand, these techniques in multi-party computation and secure computation can be used to add usability features or usability studies to applications without introducing new privacy cost or compromising any privacy guarantees. So this relevant UI data can be collected without sacrificing that or exposing any individual user's data. Thank you all for listening. I'd like to also thank our other collaborators. And if any of you are interested in doing a similar deployment or just seeing some of the work we did, all of the code is open source and online on GitHub. Thank you very much.
OK, any questions from the audience? People going to their seat or asking questions?
Hi, I really appreciated your talk and somebody with a multi-party computing background thinking about usability. My question is about the fact that the two things at the very top about trust and validity of the results, I'm going to tell you as a data scientist, if I'm doing anything with data, I don't trust anything until I see it with my eyes that it's clean, because data is so messy and so erroneous. So what is your thought in the ability in a system like this to give a few chips to each submitter so that they can actually really trust? So this has to do with trusting that algorithms will always be perfect regardless of what goes in. That's just not something I have. So if rather than saying, you know, just trust us, we got this, just trust us, that just doesn't work for a data scientist. So if you have the ability to give the data science some peaks so that they can actually look at the fact that I put this in, it's coming out at the other end, I think that's the start of a data scientist wanting to even think about using multi-party computing, and I was just wondering if you had any thoughts on that.
Yeah, so one thing that is possible would be something like doing sampling under MPC to see that a small portion of the output is statistically representative of the larger output. But specifically in our case, we've guaranteed to the companies that no individual company's data will be seen by anyone, because that's a potential privacy leak that they're not willing to accept. In terms of the validity of the data going in, that's part of why we've focused so much on having the input be very standard and something that users are familiar with. For example, most of the data they submit is in a format that they compile data for the EEOC. Maybe Lucy can fill in on what that acronym stands for.
The Equal Employment Opportunity Office.
There we go.
Yeah, something of that sort.
So we hope that that data is consistent with, or their data is consistent across those two forms, and will hopefully be correct in that input.
And aside from that, when it comes to output validity, right now we're just capturing the average, but that average still matches up with statistics that we've seen across the country. So if we look back at the results, like what they've seen is that the wage gap is around 76 cents for women compared to men in the Boston area, and that actually is a underestimate of, it's worse than what they actually anticipated for Boston. They thought it was more likely around 80 cents. So the output validity is close enough to what they would expect that I think that also helps with getting trust in the computation itself. And also right now, we are just looking at the average, but in the next deployment, we've also added things like standard deviation, and I think as time moves on, we can make that computation more robust by enhancing it, but it does come with a trade-off of performance overhead, so those are things that we're working on.
We have time for one more.
Great, thanks. Chris Keenich, UIC. I'm really excited to see MPC going into the real world like this. I'm wondering, kind of at a very high level, these questions that you're going to be asking and saying, oh, we're going to guarantee your privacy, no one will ever see that you actually lied about these numbers. So, like, is there some kind of like threshold level trapdoor that you could say, like, oh, if everything looks how I basically understand it, then everybody's happy, this is how it's going to work. But there are motivations to lie because you know no one is looking. But if you could say, oh, well, if we have this idea somebody's lying, I could say, oh, well, 5 of these 15 companies all agree to say, yes, we would like to deblind this. Is there any sort of option to do some deblinding to kind of make sure that the true numbers are being submitted?
Yeah, so not yet. So something that we have seen is that like I mentioned, the numbers are a lot worse than we thought. So if companies had an incentive to lie and say they participated in this compact, they would likely want to say, oh, look, we're not so bad after all, everything's fine. But in fact, it's the opposite. The numbers just look a lot worse than like people would have initially predicted. So also, I think a key reason why companies participate now is that they don't want the results attributed back to them. So they don't want anyone to know that they contributed to the data so that they can still say, we're in this broader compact, but we didn't actually contribute to this particular deployment, so don't look at us, it's not our data. But yeah, we have not explored something like the blinding idea you discussed.
Thank you.
Okay, let's thank the speakers yet again.